So we've seen some important ideas in our examples. We're just going to tie them together with a theorem. So our first theorem says if there's a pivot in the augment column of a matrix that's in reduced row echelon form, then one of the equations in our system is 0 equals 1. There will be no solutions. Let's unpack this a little bit. So our hypothesis is that there's a pivot in the augment column of a matrix that's in reduced row echelon form. A pivot is our first non-zero entry in a row for a matrix in reduced row echelon form. So what does that mean? That means that looking at this row, let's write down an example of this row. We're going to be all zeros, 0, 0. We have all zeros until we get to the augment, at which point we have our pivot. And since we're in reduced row echelon form, we know that that value is going to be equal to 1. So the highlighted part, there's a pivot in the augment column of a matrix, means that we're going to have some row that looks like all zeros until we get to the augment and then a 1. And we know how to read this off. That means that we have 0 times each one of our unknowns. We sum them all up. They're all just equal to 0. And then this is supposed to be equal to 1. Well, that's never true. This is inconsistent. Okay. So that having a pivot in the augment column of a matrix in reduced row echelon form means that we have encoded the equation 0 equals 1. And because that's not true, there are no solutions. All right. Great. Our second theorem says that if there's a pivot in every row of the reduced row echelon form of a coefficient matrix, the coefficient matrix, remember, is this is left of our augment, columns that are left of our augment. And no matter what our augment is, the system is always going to be consistent. Okay, so we see that we're going to have a pivot or a non-zero entry in every row of our reduced row echelon form of to the left of the augment. So notice that means that we have a non-zero entry in every row left of the augment. And just so that we feel better, notice that means that theorem 1, that situation where we have all zeros on the left of the augment, is not going to apply. And we'll see that we can write down a solution. So our solutions have the form where pivot variables are functions of our free variables. So what we're going to see is that we have we can express every pivot variable in terms of our free variables, and the free variables will just be themselves. So, so we can just write down our solution set. Okay. All right. And so in the case that we see a pivot in every row, then we're going to see that our system is always consistent.